So a little review on radicals. If we have square root of 9, that just means what number times itself equals 9, right? Which would be 3 times 3.
Mm-hmm.
So the square root of 9 equals 3. If we had the cube root of 8, that's what number times itself 3 times equals 8. Here that would be 2 times 2 times 2. So cube root of 8 equals 2. If you have square root of x squared, these cancel each other out, and you're left with an x. That'd be the same for cube root of x cubed, fourth root of x to the fourth, things like that. And then remember, you can't do an even radical of a negative number. Because if you had square root of negative 9, you need two numbers that multiply itself to get negative 9. Well, your options are like 3 and 3. Those aren't the same, or it does not equal negative 9. Negative 3 and negative 3. That also equals positive 9. And then negative 3 times 3 gets you negative 9, but they're opposite signs. So those also don't work. So you can't take the square root of negative 9 right now. In a few weeks' lessons, we'll learn how to do that. Imaginary numbers, you might have done those before. But for now, can't do that. Okay? So when we combine like radicals, they must have the same radicand and must be the same radical. So radical is that. It's the check mark box thing with the index, the little tiny number up top. The radicand is the number inside the radical. So square root of 2 plus the square root of 2. How many square root of 2's do we have? 2, right? So that would just be 2 square root of 2. Because adding just, when you're adding, you're counting how many of the same thing do you have.
So do you treat it like a variable?
Basically.
Like x? Okay.
Square root of 2 plus the square root of 3. That can't be simplified, so you just leave it. Like it's an x and a y, if you go with that variable example. Cube root of 2 plus square root of 2 can't be reduced or combined. And then like if you had the fifth root of x plus 3 fifth root of x, that would be 4 fifth roots of x. Alright, so just some examples, very similar to what I was just telling you. You don't need to write these down if you don't want to, because we just wrote down similar ones. Yeah, if you notice, same radical, same radicand. So same number on the inside, and it's the same radical on the outside, same thing. It doesn't matter, the outside number, the coefficient, so the 5 and the 3, those don't matter. They can be whatever they want to be, just whatever's on the inside. All right, so go ahead and practice those. All right, and multiplying, dividing, life's real easy. You multiply what's on the outside and you multiply what's on the inside. Doesn't matter what's going on. They do have to have the same radicals though. So it has to be, both of them have to be like cubes or square roots.
So is it like FOIL, or do you multiply them by each other?
Depends on the problem. So if it's all multiplication, so actually, yeah, whatever. here, you can rearrange that to be 3 times 4 times square root 5 times square root 6. So it'd be 12 square root 30.
Okay.
The FOIL, which is a good question, whenever there's plus or minuses, your life gets much harder. Here you have to FOIL that. So you would do 4 times 3 is 12, which I think this is later lesson, that's fine. Plus 4 square root 6 plus 3 square root 5 plus square root 30. But if it's all multiplication or if it's all division, you can just rearrange it and do like things together.
Cool.
A few examples you can copy down. You can go ahead and try these problems out and I'll go over them. All right, so 9 times 4 is 36. Square root of 2 times square root of 2 is square root of 4, which would be 36 times 2, 72. Next one is 10 square root of 60. So to simplify radical, you would do, basically you find a factor pair that goes into 60. Here, it would be 4 and 15. So 4 times 15 makes 60, right? So that means I'm going to rewrite the square root of 60 as the square root of 4 times the square root of 15. This is a whole longer process than I normally do. Then you can split that up into 2 multiplication parts. And then square root of 4 is 2, and 2 times 10 is 20. Here you can just divide 30 by 5, so 2 square root 6. And then here, 2 square root 4, which would be 2 times 2, which equals 4. Simplifying radicals, convenient. So if we have square root of 72, a couple of ways you can do this. One is if you find a perfect square that divides into it. So here I know 36 and 2 work. 36 is a perfect square, so I can split this up into square root of 36 times 2, which is, that's square root of 36 times the square root of 2, which would be 6 root 2. If you have one that you can't figure out, but you're like, I think it might be something like 256. It's a pretty big number. I think something goes into it. So that would be 2 and 128. 128 is 2 and 64. And right there I see that 64 is a perfect square, so I can stop. I'll see I've got 2 pairs of 2s. So 256 actually works out pretty nice. Square root of 256 equals 2 times 2 times 64. When you got the pair of a number, one of the numbers comes out, the other one goes away. For 64, that's just 8. And since all of these simplified, there's nothing left there, so it just disappears, and you're left with 16. Some examples. This top one, 12. If you split up into 6 and 2, well, it seems like there's nothing that can work there, right?
Wait, hold on. Did the last one say the square root of 72 was 16?
I don't know, I might have had a typo.
What?
But if you split it where you have a perfect square of 4, and then square root of 3, you can then simplify that to 2. So square root of 18, I know 9 and 2 work there. So the 9 gets simplified. Square root of 9 is 3. That comes out. And the 2 is left behind, because there's nothing to simplify it with. 90, I'll go through these. 90 would be 45 and 2, which would be 9 and 5, and 9's a perfect square. So that 9 gets simplified to 3. Square root of 9 is 3. And then the 2 and the 5 are left behind, so that'd be 3 square root 10. For square root of 27, that's 9 times 3 as well. So yes, there's 3 3's there, right? But we only need a pair because it's a square root. So one of these 3's comes out, that one's gone, and then the last 3 is left behind. 200 is 100 times 2. So that'd be 10 square root 2. Square root of 50 is 25 times 2. So that'd be 5 square root 2. 24 is 4 and 6. That one always feels like it should have more, but it's just 2 square root 6. 72 is, we did that one earlier, 4 times 6, square root 2. This is what this simplified to, and then you multiply the 4 by the 6, and you get 24 square root 2. Square root of 30, can't simplify, because that would be 6 and 5, 2 and 3. 2, 3, and 5 don't share. 125, that's lots of 5's. 5 times 5 times 5. 2 of those come out. Or 1 comes out, 1 goes away. And then there's a 10 out front, so it's 10 square root 5. That's all. The last thing that you'll need to do on these problems is rationalizing the denominator. All that means is if you have a radical in the denominator, we don't like that. So we multiply by whatever's in the denominator. Square root of 3 by square root of 3 here. Because square root of 3 times square root of 3, I'll work it out, but hopefully you get used to just being able to see it, is square root of 9, and that is just 3. So we prefer our answer like this. It's the same thing. These two numbers, if you type them into a calculator, equal the same decimal. But this is the answer of how we want it written. Okay, so if you ever have a radical in the denominator, you just multiply top and bottom by that. There'll be some other complicated ones we'll get to at some point, like if you have 4 over 2 plus square root 2. It's a little more complicated, but we'll get there.